Yes, welcome back. Good evening to everyone. Let us see one more beautiful presentation this evening on finding the transfer function of given signal flow graph diagram. Okay, so this is lecture number 9. This is in which we will see one example of finding the transfer function of a given signal flow graph diagram. Okay, for your better understanding, I am considering a very simple, brief example so that you can, so that you will able to understand how the steps which we have seen in the last presentations are applicable, or how these steps are to be applied for this example in order to obtain the transfer function of a given signal flow graph. Okay, so I am considering a simple example. So let us consider this as a given example. Let us R of s, and then this is your C of s. This is given as 1, the gain. Here the gain is, let us say, G of s. This is 1 again, and between here to here, let us assume it is H of s with a negative sign. Likewise, the signal flow graph will be asked in our examinations. Find the transfer function. Find the transfer function TF for this given signal flow graph. That means that you are asking that TF is nothing but your C of s by R of s. The ratio of C of s by R of s you need to find out for this given signal flow graph. This you need to find out for the signal flow graph. So for this, what we have seen in the last presentations, we have seen 4 excellent rules which are to be applied for the given signal flow graph. So now I am going to solve for you. Okay, in step number 1, what is our step number 1? What we have seen in our last presentation, in step number 1 we have seen that the number of forward paths, with their path gains, in the given signal flow graph diagram. You have to find out the number of forward paths with their path gains in the given signal flow graph diagram. So carefully observe that if the problem is given like that, you immediately note down that the first point as the node 1, R of s should be considered as node 1, and after that this can be taken as node 2, and the third one can be taken as node 3, and the C of s can be taken as, or can be considered as node 4. So in the given simple example, we have 4 nodes: node 1, node 2, node 3, and node 4. And again, from node 1 to node 2, in between 1 and 2, means in between node 1 to node 2, there is a arrow mark is given, means that the flow of the signal is directed towards node 2 with some value is given, that is 1. That is nothing but the gain of that path, the gain of that path between node 1 to node 2. This is gain. 1 is nothing but your gain. And similarly, from node 2 to node 3, again there is a arrow mark towards forward direction. The signal is still it is going to forward direction. It is started from R of S. Your node 1 is nothing but your R of S, and the signal is started towards forward direction and it is reached to node 2, and again from node 2 to node 3 again it is going forward direction, and between node 2 to node 3 G of S is identified, means the gain of the available path. The gain of the path between node 2 to node 3 is nothing but G of S. That is the gain again. This is the gain again. Okay, then again from node 3 to node 4, again the signal is directed towards again forward direction, reaching to your C of S, node 4. Here between 3 to 4 it is identified with gain 1. Therefore, if you see from R of S to the C of S, okay, there is one straight path is available with directed as forward direction. So from here the arrow mark is forward direction, again forward direction, again forward direction, means you can consider it as a forward path. Sorry, you can consider this as a forward path, nothing but your first forward path as far as this example is concerned. Okay, therefore you have one forward path. Okay, then say for example, is there any forward paths as per this step 1? Is there any other forward path is available in this example? If you see again from node 1 to node 2 there is a direction, forward direction, and this is already we have considered. 2 to 3, 3 to 4 we have considered, taken into as forward path 1. Therefore, now the other possibility is that 1 to 2, 2 to this one. Let us say for example, if you see 2 to 3, the arrow mark is showing reverse. It is showing a reverse direction. It is coming backward. Therefore, you should not consider this as forward path. This will not be the forward path. Therefore, as far as this example is concerned, you have only one forward path, and that forward path is identified by P1, the letter P1. P is the forward path. 1 is nothing but, suffix 1 is nothing but one forward path. Only one forward path is available. Good. Therefore, P1 is the forward path, and then along with their path gains, forward path nothing but P1 with their path gains. Path gains means, so you have to take the product of all the gains available on that path. What is the gain available? What is the first gain? 1 into the second gain, G of S, into what is the third gain? 1. Means between node 1 to node 2, what is the gain available? Don't confuse here. Between node 1 to node 2, what is the gain available? That is 1. 1 into, again node 2 to node 3, what is the gain available? G of S. And similarly, node 3 to node 4, what is the gain available? 1. Therefore, gains shall be multiplied, means 1 into G of S into 1. Therefore, 1 into G of S into 1, that is equal to simply your answer is G of S. Understood? Therefore, your forward path, only one forward path is available, that is nothing but your P1 is nothing but G of S. Okay, other than P1 means other than this first forward path, there are no other forward paths. Forward means the signal should flow from R of S to C of S only. That should flow in the forward direction only. That should travel towards the forward direction, okay, in the direction of reaching to C of S. That is destination. Therefore, as far as this problem concerned, you have only one forward path, and with the path gain is G of S. That is your step number 1. Clear? Now, coming to step number 2. Step number 2, I will write for you. Remember this. And what is step number 2? I will write for you. What is step number 2? So, in step number 2, it describes about the number of individual loops. What is the number of individual loops with their loop gains? With their loop gains. That is the second step. The number of individual loops with their loop gains. So, as far as the given signal flow graph is concerned, what are the individual loops that are available in the given problem? You have to identify the loops, individual loops. I already explained in the previous session that in my previous presentation, what is a loop? Loop is nothing but it is something like this. So, for example, if you consider here from node 2, the path is going forward direction up to 3. From 3, again it is coming backward, reaching to node 2. Means the signal should start from particular node and again it should end, it should complete, it should reach to the same node. If it is the case, then it is said to be a loop. Then it is said to be a loop. Therefore, in this case, for this given problem, for this given example, you have one loop is there. So you have one individual loop. Therefore, how many individual? The number of individual loops means you have to write we have only one individual loop. So, individual loop, one loop. Therefore, that loop is identified by L1, L1, L suffix 1. That is, L means individual loop is identified by the letter capital L, and as you have only one loop, that is represented by L suffix 1. Therefore, L1 is equal to, so this is your individual loop with the loop gain, with their loop gains. Means for this available loop, what is the gain? What is the gain? Nothing but the gain available on that path. Now tell me, what is the gain available for this loop? So from 2 to 3, the gain is G of S. The gain is G of S, and again from 3 to 2, it is going backward direction with a gain minus H of S, means that minus H of S. Is it not? This implies you take this minus here, then it is G of S into H of S. That is what your L1. You can put in a box like that. This is your step 2. Therefore, as for step 2, your L1 is equal to minus G of S into H of S. Now, you may have one doubt that, sir, what is minus? Then, what is minus here? Minus is nothing but it is a negative feedback loop. Simple. Okay. If it is a minus, then this is a feedback loop. Is it not? This is a feedback loop with the, okay. So, H of S is the feedback gain, and this arrow mark is reaching at node 2, minus sign means it is a negative feedback loop. That is the meaning of it, negative feedback loop. Therefore, if it is given minus, as it is, you have to consider that minus. If it is given plus, for example, if minus is not given here, means you have G of S and then H of S. If plus is there, then it is nothing but a positive feedback loop. Then this loop is called a positive feedback loop. So as far as this concerned, minus is given, therefore it is a negative feedback loop. Therefore, what is the loop gain here? You have only one loop, and the loop gain is nothing but this, minus G of S into H of S. That's all. That is your step number 2. Now, coming to step number 3. What is your step number 3? I will explain. What we have seen in step number 3. What is step number 3? So, your step number 3 describes about the number of 2 non-touching loops and 3 non-touching loops. Number of two non-touching loops. Two non-touching loops and three non-touching loops. Non-touching loops. Okay, this we have to identify. Means in the given exercise or in a given problem, is there any possibility or is there any availability of two non-touching loops? Means there must be two individual loops and they should not to touch each other. There should be present two individual loops and they should not touch each other. That is the meaning of two non-touching loops. And similarly, three non-touching loops means if 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 there are three individual loops and these three should not to touch each other. Okay, then if you apply this step number 3 for this example, the answer simply you can say, you can write here that there are no, you can write that there are no two non-touching loops. There are no two non-touching loops and three non-touching loops. Is it not? So you can write like this: there are no two non-touching loops and three non-touching loops are available in the given problem. Therefore, so step number 3 is completely not applicable to this problem, because as we don't have any two individual loops or even three individual loops, therefore step 3 is not applicable for this problem, because you have only one loop. Therefore, straight away you can say that your step number 3 is not at all applicable. Now, coming to your step number 4. What is step number 4? What is step number 4? Step number 4 is nothing but directly, it is nothing but the formula. That is nothing but directly, I already explained in the last class, that last session, TF is equal to, so it is 1 by delta and sigma, it is K is equal to some 1 to n Pk delta K. This is your, as per step number 4, this is your formula. In this formula, you have to, as per this formula, you have to identify your transfer function. Now this is equal to, here what is K? K is nothing but a number of forward paths. Okay, P number of forward paths only. K is also associated with your forward path only. So here the value of K is 1 only. Means as the number of forward path is 1, then your value, K value is also equal to 1 only. Therefore, if you expand, if you substitute that one, that K is equal to 1 in this, then you can have this like this. That is 1 by delta in bracket, because now as I am substituting K value is 1 here, then there is no need of mentioning the summation again. Directly you can write P1 and then delta 1. That's all. Means P1 delta 1 by delta. This is nothing but your P1 delta 1 by delta. This is what your TF. Okay. So I will better explain again here. This implies TF is equal to, it is P1 delta 1 by delta. This is equal to, what is P1? P1 is equal to what we have seen. P1 is from your first step, 1 into G of S into 1. Nothing but your G of S, means it is G of S only. P1 is equal to your G of S. Then what is delta 1? Delta 1 is nothing but, it is the value of delta with respect to forward path P1. Forward path P1. That means that that means that as you have the first forward path P1, and with respect to this first forward path you have one loop, and that loop, whatever the loop is available with respect to the first forward path, that loop is touching to the first forward path, then delta 1 value becomes 1. Okay, otherwise simply you can say that delta 1 gives the value of loop, actually that describes about the value of loop. It's not the value of loop, and it is something relation between the loop and then first forward path. If the loop which is associated with the first forward path, and if that loop touches to the forward path, then you can consider, you can give the value delta 1 is equal to 1. Therefore in this case delta 1 value is 1. Why? Because delta 1 is nothing but the value of delta the value of delta associated with the first forward path. How the delta 1 will be identified? Delta 1 comes from the loop, individual loop that is touching to that first forward path. Therefore in the given problem we have first forward path and again we have one loop, so that available loop is touching to the first forward path. Then if it is in this case, your delta 1 becomes 1. Therefore it is g of s into 1, nothing but your g of s by what is by delta, means g of s by delta. Okay, g of s by delta. What is delta? Further, how we should find out the value of delta? I erase this problem and I will explain here. So your transfer function means now we are finding the transfer function, nothing but we are in the step number 4. So as per Mason's gain formula, T of s is equal to, what is your final step? It is g of s by delta we have seen. What is delta? This implies delta is equal to what we have seen in our last presentation. Delta is equal to 1 minus sum of individual loops, sum of or gain of individual loops, is it not? And plus something will come, no? Plus something, what is this something? And minus some parameter plus something, like that it will go on. So 1 minus sum of gain of individual loops plus, and here in this bracket what we have seen, it is the sum of the gain product of all the possible combinations of two non-touching loops, and here it is the sum of the gain product of all the possible combinations of three non-touching loops, the sum of gain products of all the combinations of available 4 non-touching loops, 5 non-touching loops, and so on and so forth. Means that 1 minus sum of gain of individual loops, after that it comes if it is 2 non-touching loops, and then this is for 3 non-touching loops, this is for 4 non-touching loops. So for the given problem you don't have any 2 loops, 2 individual loops, you don't have any 3, you don't have, therefore straight away you will have nothing. Means this particular is not at all applicable for you, means this quantity will not be there, it is not applicable for this problem. You have this much only, 1 minus sum of gain of individual loops only. This means delta is equal to 1 minus, what is the sum of gain of individual loops? How many individual loops you have? Only one loop only. Write that one loop, L1, that's all. That is the meaning of it. And further, this implies delta is equal to 1 minus, what is the L1 value? It is, we have seen that minus of g of s into h of s, is it not? This is further 1 minus of minus plus 1 plus, it is g of s into h of s. This is what your delta. We have obtained the delta value also. This is your delta value. Therefore, substitute this delta value in this transfer function. You substitute this value directly here. Then what you will have? Then this is equal to TF is equal to this. I can write here G of S. I will erase this. If you substitute this value, whatever we have obtained in this, then you have transfer function is equal to, it is G of S by 1 plus it is G of S into H of S. That is what the transfer function of the signal flow graph method. Okay, this is what the final answer of the signal flow graph. For the simple example which we have considered, in order to find out the transfer function, this is the answer of that. And again, this is the answer. This is the transfer function. Likewise, so we have applied all the 4 steps to that simple example, and finally we have obtained the transfer function. So can you remember that? Actually, in our first or second sessions, we have already seen this kind of a transfer function for particular system. What is that? Have you remembered that? That is nothing but, it is nothing but a closed loop control system with negative feedback. With negative feedback. Remember this in your mind, and I am going to compare this result with your closed loop control system. This is nothing but a closed loop control system. You have seen that for a closed loop control system, with negative feedback, with negative feedback, how this could be? This is your R of S, this is your C of S, this is your input signal, this is your minus feedback signal. This is what we have seen in our second session now. This is what actually, this is a closed loop control system with negative feedback. So for this is a block diagram representation of a control system, whereas the example which we have considered is nothing but the same system with signal flow graph representation. And for this block diagram representation, for the negative feedback, we have already seen the result, the transfer function C of S by R of S. In block diagram reduction, C of S by R of S is equal to, for negative feedback we have seen that it is G of S by, it is 1 plus G of S into H of S. This we have already seen. Means by way of this, what I want to convey is nothing but, so the known, we already know this. For a closed loop control system with negative feedback, the C of S by R of S, nothing but your transfer function is equal to G of S by 1 plus G of S H of S is already we have seen and we have studied in our previous sessions. In today's presentation, we have verified the same result of this block diagram with the help of the signal flow graph. So even with the signal flow graph, you must obtain the same result, whether we have obtained or not. Absolutely, we obtained the same. So what I mean to convey is that the beauty of the signal flow graph is nothing but the signal flow graph, or otherwise the block diagram problem can also be solved with the help of signal flow graph. This block diagram can be converted into signal flow graph, and with the help of, by applying these 4 steps, you can find out these transfer function. Okay, so and I would like to conclude this session with the simple last by giving you the final touching of this. In this is the given block diagram. How I will convert this block diagram into signal flow graph? Nothing but very simple. I am converting this block diagram into signal flow graph. Carefully see. This is R of S. You should consider it as a node. This is your summing point. This is your takeoff point. Have you remembered or not? This is your takeoff point. This is your summing point. This is your input. This is your output. And your input and output should be considered as a node points. You first remember that. Your input R of S as well as your output C of S must be considered as a node point in signal flow graph. That is the first point. And secondly, all the summing points and takeoff points must also to be considered as node points. Then obviously this is your first node point, R of S. You can identify like this: 1 summing point, give 2 for this, give 3 for this, 4 for this, finished. Then it is your first one, and this is second node, this is third point, and this is your fourth point. Okay, this is 1, 2. What are the points available? You can give in continuation, means give as node 1 to the input, whatever, maybe summing or takeoff, whatever it is, give the second, you consider it as a node and assign a number for that. As it is a summer, I am giving 2 for this, therefore, and then after that takeoff point is there, then I am giving 3 for that, and finally my C of S, that is 4. Means again this 1 is nothing but my R of S, and 4 is nothing but my C of S. And now these are what? Node representation. Okay, now from 1 to summing point, arrow mark is there. Simply if you have arrow mark, what is the gain of that arrow mark? If nothing is given, just assume that the gain must be 1. Therefore, represent as 1. Because if nothing is given, that means that the gain must be 1. And similarly, 2 to 3. So 2 is the summing point, 3 is the takeoff point. In between 2 to 3, G of S is given. This is the gain actually for this path. Arrow mark is represented like this, no? So this means that this arrow mark is starting from 2 reaching to 3. Therefore 2 to 3, between these 2 points, this is the gain. Therefore 2 to 3 you mention as G of S. And again takeoff point 3 to this node 4, what is simply straight line is there, means that nothing is given, assume that the gain must be 1. Between 3 to 4, the gain must be 1. Understood? Then again from takeoff point 3, you are giving feedback with negative feedback, because the arrow mark is reverse direction, then you can show that reverse here also, nothing wrong in that. Means the portion of output is taken back through this feedback network we are giving to the summing. Means that there is a loop between 3 to 2 actually. From 3 it is coming as like this, reaching to 2, means 3 to 2 you have a loop. Which loop? It is coming negative direction, means reverse direction, means 3 to 2 you represent like this. Give arrow mark in reverse, then H of S is the H of you give H of S here, and it is reaching to minus sign, therefore minus will come here. This is the signal flow graph of that block diagram. Very clear, very simple. Therefore, likewise, any big problem, any block diagram problem can be converted into equivalent signal flow graph. And for this signal flow graph, if we apply those beautiful steps 1, 2, 3, 4, then you can easily obtain or identify, you can find out the transfer function of the given block diagram. Okay, so thank you so much. I would like to conclude this presentation with this, and we will see you in the next presentation. And I request you all, if you have any comments or suggestions, you feel free to comment on my channel, okay, so that I will consider them on very high priority, and definitely I will give you the best output, and so that it will be very useful for me to improve in the further subsequent sessions and then presentations. If you like this, definitely don't forget to share with your friends, so that most of the students and who are studying the BTechs and who are preparing for the competitive examinations shall take part in that, and I wish uh, to uh, to get the maximum benefit out of these presentations. Thank you so much.